I did a PhD and a few postdocs, and every time I've built in various languages softwares to do data acquisitions from many different kind of instruments, and I've been really fed up with that. I don't know how you say in English, but we say in French, I was fed up de réinventer la roue.
And that's French for reinventing the wheel. And who wants to do that? Certainly not Sébastien Weber, my guest for this episode, who decided to create an open source software library to make him and others stop to do the same thing over and over again. The tool is called PyMoDAQ, and in the next few minutes you're going to find out what it is, how it started, and how you can use it for your own experiments. So there it is, the great machine doing your experiments. But how do you get the data out of it? Manufacturers usually provide so-called driver software that allows to connect the device to your computer, for instance. Or maybe even an app or some software tool that takes the burden away to write the control of the device and everything else you need, like the task of running an experiment, collecting and transferring data from the device to your computer, and so on. If the machine is bespoke, chances are that you or someone has to do much of it from scratch. Of course, when you move to another machine, another setup, you'd have to start all over again. And that is what Sébastien Weber, a physicist from Toulouse in France, was talking about when he said he's fed up with reinventing the wheel. So how about writing an open source software tool that allows you to extend the catalog of experimental machines through plugins and extensions? A framework that can be used not just by one experiment, but by any. And this is exactly what Sébastien did when he wrote PyMoDAQ. But it's not all plain sailing when it comes to create an open source software tool, as you'll hear in the following conversation.
So hello everyone. So I'm Sébastien Weber, or Weber in French, and I'm a research engineer at CNRS in a laboratory called CIMES in Toulouse, France.
Your library, it's a Python library called PyMoDAQ. Could you quickly give us an overview of what it actually is and what it does?
So PyMoDAQ is an open source software allowing experimentalists to build very quickly user interfaces to orchestrate their experimental setups and automatize data acquisitions.
Data acquisitions in terms of hardware devices like a microscope, or what can we envisage? What kind of devices are we talking about?
That's exactly the point about PyMoDAQ. It doesn't focus on specific instruments, but is really dedicated to be able to control and orchestrate any devices on any experimental setups. So obviously there is a library of compatible instruments at the moment, and that's why it's a collaborative project where people are all the time adding new instruments compatible with the library, allowing other people having the same instruments to be very efficient in building interfaces to control their apparatus.
If we drill down a little bit with a name, so it's obviously an acronym, so PyMoDAQ. So Pi stands for Python, DAQ for data acquisition, and what does the MO stand for?
So the MO is a very important part, in my opinion, because it stands for modular. And since the beginning of thinking about PyMoDAQ, this was the art of the thing, being able to be modular and adapt itself to any kind of experimental setups without knowing beforehand what it should do afterwards.
Okay, how old is it actually? So when did you start creating it?
I thought about the concept back in 2014. And I started to build it just after, during my postdocs. So at the time I was in a postdoc at CEA in Paris. And then I pursued that. And actually I've been hired in a permanent position as an engineer at CNRS in 2017. And that's when the open source Python project really been born.
So it's been going on for quite a while. So when you started thinking about it in 2014 and then started working on it in 2017, it's now 2025. So it's been going, you've been doing it for 80 years at least.
Yeah, well, it takes a while to really put things together, confront it to reality, and having feedback from other colleagues, users, and having it as it is now. Yeah, it took a while and a lot of work, many line of codes. But I'm very proud to say that it's now in a shape where it's very handy and useful to a lot of people.
And we're going to come to that in a bit. But first of all, you're not a software engineer by training. I mean, you work in science and research. What kind of data acquisition are you usually dealing with?
Yes, I'm a physicist. So I'm building here in my lab instruments for helping experimentalists and researchers to do spectroscopy on nanomaterials. So most of the time I'm taking data out of a spectrometer or lifetime measurements from devices measuring events as a function of time out of the interaction between a laser and a material that could be nanoscale or microscale. And we are looking at the properties of these materials depending on their environment and how we build it on the nanoscale.
The reason I'm asking is you obviously had to get data from these devices. And my question now is really, what made you develop PyMoDAQ in the first place? Because surely some solutions must have existed at the time. So what was the reason for creating PyMoDAQ?
Actually, there was not really solution. There was software that could allow you to build your user interfaces to drive your instruments or get data. But every time you have a new instrument or a new experiment, you would have to go from scratch and build a new thing that would be doing more or less the same thing as what you did before. And that's really how I started PyMoDAQ, because I did a PhD and a few postdocs. And every time I've built in various languages softwares to do data acquisitions from many different kind of instruments. And I've been really fed up with that. I don't know how you say in English, but we say in French, I was fed up de réinventer la roue all the time. And that's why I started to think about that and propose and train people to not reinvent the wheel. I guess that's how you say it, all the time. And it doesn't matter what kind of instrument really you have. PyMoDAQ is able to deal with data that could be from a camera or from an oscilloscope or from whatever detector you have.
Yeah, and that puzzles me a little bit because back in the days, I used to work in medical physics for a while, and we had to interface for the project. We had to interface with a particular tape device, which was very bespoke. And so I wrote a driver for, connecting the computer to the device and getting the data. And surely that's what you have to do as well in order to actually connect your computer with the device in order to download the data. And surely that must depend on the hardware itself. So there's always a little bit that you have to reinvent anyway, isn't there?
Less and less, I would say. You're right, because most of the time, manufacturer of devices that just give you a library in whatever form they like or what. And you have to do the work. You have to do the work to translate this in Python, to use it with PyMoDAQ. So for sure, you have to do this work, except if other people are doing it for you and you can reuse that code. And that's where Python is very, very interesting, because the community is so huge that you are very likely to find that other people already did this piece of driver that you are interested in. And that's the first thing. And now that Python is so used everywhere, manufacturer tends to ship instruments directly with a Python driver. So that makes things even easier to incorporate this instrument into PyMoDAQ.
Okay. In the days, the driver was actually in C, so it was a very low-level thing. Well, not that low level, but C is a high-level language. But it was a C driver. But nowadays, manufacturers also provide Python drivers. Is that what you're saying?
Yeah, most of the time there's still the C library. Either you do your own wrapper translating the C function in Python function. But
Mm.
now, more often, you'll get the manufacturer providing you this Python layer doing the translation directly. And then you have only to focus on incorporating this driver into the PyMoDAQ ecosystem, which still need a bit of work. And that's where I'm really focusing my training sessions on, for people to be independent and being able to incorporate any instruments into the library.
When you created PyMoDAQ, what were the difficulties that you faced at the beginning? I mean, how did it get started and what kind of obstacles did you have to overcome?
At the start, it was for my own purpose, obviously, and for the purpose of my direct colleagues. And when I entered CNRS, I actually entered on a project where people here were building a unique apparatus, kind of unique in the world, where it's conjunction of a femtosecond laser and electronic microscope. And they've built that for 10 years. Somehow, before realizing they didn't add software to control that
Yeah.
that guy. So I jumped in and proposed what I already did for other experiments, and really PyMoDAQ and the experiment built together. So we faced problems in controlling this instrument, and that's what really helped PyMoDAQ to develop and also to advertise PyMoDAQ, because if PyMoDAQ could control such a complex experiment, it could really be used for many others, and that really helped. But the main problem was to let people know about PyMoDAQ, and that's a very long work, and it's still going on. But
Yes.
I'm very proud to say that nowadays you can meet people in conference and they would know
All right.
about PyMoDAQ.
That's quite a success story then, isn't it? So if we focus a little bit on the technical aspects again, I mean, we touched on that a little bit with the drivers and all of that, but you have to kind of put all of that together. So could you give us a broad overview of how PyMoDAQ is actually built and how people can, if they want to develop their own drivers, use that with PyMoDAQ?
Actually, it's important to say that PyMoDAQ is modular, but could also do specific things. And they are not antagonists. You can do both. So basically, the modular thing is related to the fact that you can, at any time, control any devices in your setup. So basically, at startup, you have a dashboard, and you will use that dashboard to configure somehow your experiments, telling what type of device you have, and you create a configuration. And from that configuration, then you can directly start the user interface with all the components needed to control your experiment. So it's really modular in the fact that this dashboard allows you to control, I would say, manually from the computer, all the devices. But then when you've done that, you really want to use your computer to make things more automatic. So you will start extensions. They are a piece of software algorithm that will take control of the dashboard and the control modules of the devices, of all the devices. And they will create the more focused task of acquiring data, optimizing a signal, logging data as a function of time, or whatever else you may want. And there's two things people can do to develop PyMoDAQ. It's either create plugins to add their driver and their apparatus in the library, or they could build also extensions to add more thematic or focused task to the generality of PyMoDAQ.
That dashboard, is that some kind of a web application or is that a standalone UI?
Everything in PyMoDAQ is based on the Qt framework. So Qt is a well-known C++ library that's been used by many softwares to create user interfaces.
Okay.
So there's some other Python project called PyQt Graph. It's using Qt, but build many advanced widgets, user graphical components, to be used for science. I mean, to display complex data, to create many settings to control an apparatus, for instance. And PyMoDAQ used this framework, and so it's a standalone component, and many widgets, many windows can be open, one for the dashboard, one for the extensions, and you control your experiment from this Qt-based application.
And Qt is cross-platform.
Yes, so both Qt and Python are completely cross-platform. So it means that you can use PyMoDAQ on any computer, even very small computers such as Raspberry and the likes.
Well, Python certainly runs on Raspberries. I didn't know about Qt. You also mentioned the difference between plugins and extensions. So I think we need to help the listeners perhaps understand this a little bit more, what the difference is and which ones you would use under what circumstances.
The PyMoDAQ that you can download and install will just be the core components and all the graphical things that you will need. Then, if you want to use some instruments, you will need to download the plugin corresponding to your instrument. So,
yeah, and if I can interject there, where would they download it from?
Okay, so as most of the Python projects, you can directly download them from the PyP server. PyP is the main server where people host their Python projects and package. So you can easily download that and install it. And then for each instrument that you want to control, there is a package, a Python PyMoDAQ package that you can download and install. And PyMoDAQ will look for those and allow you to instantiate the control of given instruments if the corresponding plugin has been installed. That's one part of what a plugin can do, but a plugin may contain many other functionalities, extending the functionalities of PyMoDAQ. And I mentioned the extensions. There is shipped extensions with the core of PyMoDAQ, but you can also create your own and put them in plugins and download and install them whenever you like.
In other words, so the plugins is something that you can download and use ready-made, if you like, from PyPy or any other Python distribution. But if that isn't enough for you, then you need to build your own extension, which you can then again make available to the public by turning this into a plugin so other people can download it.
Yeah, that's the point. If you don't find the functionality, either the driver for your instrument or the extension doing the job that you want to do, there is special objects and scripts that will allow you to add these into plugins that you can deposit on PyP for other people to use, or just yourself, but still have it available.
You mentioned that you're a physicist and you work with spectroscopy in material sciences. Is PyMoDAQ specifically for this area of research, or do you think that it can be used in other areas as well? And have you actually encountered people who use it outside physics?
It's difficult to reach somehow people outside your own region of interest at the beginning because you're advertising it in your community. So many people in physics and in particular in optics, because they are my friends, my colleagues, so it's spread from there first. But often people are telling me, PyMoDAQ is only for optics. All your examples are within optics. And I say, yeah, well, I know only optics, that's why, but I'm willing to help you build and use PyMoDAQ in other areas. And now it's starting to cross the gap between the various communities in science, and people are starting to use it for biology, chemistry, and other subjects of physics that are not only optics. But for sure, the goal of PyMoDAQ is to be useful for any people who want to control their devices in an experiment, whatever is the experiment and whatever are the devices.
One question that we haven't actually talked about yet. How do people install PyMoDAQ and how do they get hold of it?
With PyMoDAQ, you enter the world of Python. From there, you have to somehow be aware of how to install and start a Python code, Python application. So there is a broad documentation for PyMoDAQ that would allow you step-by-step do the installation and also do step-by-step many other things like building plugins and so on. So basically, you install Python in an environment, in a closed environment, that would be better. And we can talk about that again. From there, you install the version of PyMoDAQ and of all the plugins that you want. And you can then start the dashboard and be ready to start using it.
The dashboard is in Qt, but people don't need to install it since this is all wrapped up in Python.
Yes, actually, the only thing you have to really install is PyMoDAQ. And then in Python packages are defining requirements, which means it's defining other packages that are required to run your application, and you will download it on the fly when installing PyMoDAQ. So you just need a valid internet connection, and then you will handle it all for you. I mean, packaging in Python has been a nightmare a few years ago, 10 years
Yes.
ago, but it started to be really nice now with really good handling of versioning, and that's good.
I guess we're talking about Python version 3 upwards, aren't we? Or are you still supporting Python version 2, 2.7?
No, I mean, when I started, Python 3 was already quite around, and I focused mostly on that. And PyMoDAQ is only available in that guy. And even more because of his many components, it's only been, at the moment, it's only usable with Python 3.8 upwards.
Well, which is not the latest version of Python anyway, I think. I'm not exactly sure where we are, but 3.12 or 13.
3.13 and one version per year.
I would like to turn away from the technicalities and more to the, well, how shall I call it? The way that it changed your career, because you started off as a physicist, but you're now doing PyMoDAQ. How do these two go together? I mean, can you still work as a physicist and can you still support at the same time PyMoDAQ?
Well, I can do both because I have a kind of a special position here in the French scientific, how to say that, I've been at CNRS or in universities in France. We have a special position ready to help people doing research. Probably there's in other countries as well, but it's quite developed here in France. So my job is to make sure all the optical experiments in my lab are working and developing a few. But then when I'm done with that, I can choose to focus my time on whatever aspects I want around this goal. And so I decided to really focus not on developing research, but on developing software to do more easily research. So I can still handle both, but obviously my time is strongly focused on PyMoDAQ. Sometimes people ask me how much time do you spend on that? Probably 90% would be a good answer.
Yeah, I would imagine so, because now that PyMoDAQ is getting more widely known, not only in the physics community, but also in biology, I would imagine that there is more demand on your time in terms of support, questions, maintenance, and you also do training, you say?
Yeah, actually, last week I've done a 4 days training. So I do that every year. It's a national training opened and proposed by CNRS. So to train internally people from CNRS and from universities also. It's taking a lot of time, but I knew about that. And from a while now, I'm trying to develop PyMoDAQ in a way that it's recognized by institutes and other universities, and trying to actually hire people to work on PyMoDAQ. Last year, I've benefited from a program called Open to develop the open source software within CNRS. And I benefited from a huge grant to actually hire an engineer to work full-time on PyMoDAQ together with me.
So, that's excellent, because that was my question. I mean, you started doing it on your own, I'm guessing. Maybe sort of you had some colleagues helping you every now and then. But being a scientist and doing PyMoDAQ as a project is probably not sustainable, in the sense that how does the project then go in future and who will carry on? Yeah, because you might want to move to something else at some stage. But you have actually the ability now to hire someone, or you already hired someone.
I mean, there's two things you can do to promote a long time survival of your open source project. The first is to bring people to join you in co-developing it. And that's really what I tried from the start, by training people a lot so that they may themselves produce codes, review code. And we are not quite there, but there are at the moment a few people that are able to understand and comment and review code and also produce things. So that's the first part. And the second part is eventually to hire someone. It's very difficult because open source software is not a model where you can make money. So it's difficult to hire people out of it directly. But CNRS and France in general has a politic now for a few years about open science and open software, and they try to promote that. And there is a few possibilities nowadays that you can use to help you develop your open source project. But it's limited in time. I mean, it's not a full-time position. So in about 1 year, we'll have to look for other source of funding to continue that like this.
Well, good luck with that. It's something that interests me quite a lot. I mean, this is the point that almost every single open source software project that I talk to is experiencing. So there's the creation phase, 1 or 2 developers start creating a project, then it becomes quite successful. And then the question is now what? Because they cannot do that voluntarily or as a side project to their daytime job, like being a physicist or being something else. Or they change their research position because often that is temporary. So they then have to move to a different job and then the project dies or it finds some funding. But they always say that in open source, the benefit is that other people can contribute too. And I would like to know from you if that's actually the case. So you've been doing this for a while now. Have you experienced that there are other people now contributing significantly to the project?
There are a few people actually contributing. Most of the people will contribute on the plugin level, where it's the easiest way of adding things to PyMoDAQ, just because you want to add your instruments and you can do it easily. So that's the first part. But then people, they are using PyMoDAQ every day in the lab. And so they want new functionalities or new features or correct some bugs and so on. And they start to dive into it. And nowadays I have many issues, but also many pull requests on the project, meaning that people are working on it. And I hope at some time this could be the majority of the work on PyMoDAQ. But it's also a drawback because if you have a lot of people working and contributing to the code, you need people to review the code and make sure the whole thing is still in working order. So there is work to do on automatic testing, reviewing, and pursuing also the kind of the politics or the view of what is PyMoDAQ and where it should go. So there is a bit of management to do also on that. But it's very exciting, actually. When I started this, it started as a very technical and instrumental project. And now I'm dealing with human resources and management of groups, organizing workshop, training sessions. It's very lively and I enjoy it a lot.
I think it changed your career a little bit, didn't it? How do you see the future evolving? I mean, for yourself, do you see that in 5 or 10 years' time you'll still be doing PyMoDAQ and physics? Or will you think that maybe it's difficult to say, I know, but...
Yeah, that's a good question. And to be honest, I don't know. I mean, it's been it's been 10 years I'm on it, and I'm still quite dedicated to it, and I don't see much change in the future. But maybe at some time, yes, I will be, I don't know, fed up with it or telling I've done all I could. I don't know. We'll see. But for the moment and the few years to come, I'm still on it.
So finally, what's in store for PyMoDAQ itself? So what does the future hold?
There's been a few developments we are working on with Malik Rain, my engineer that is working on the project with me at the moment. And by talking to researchers or engineers in other scientific communities, we realize that actually PyMoDAQ is not able to control all the experiments as it should be. And so we are looking for developing extensions to allow those people to control their own experiments. And those type of experiments are experiments where you want to do a sequence of actions before reaching a state where you can do an actual measurements and data recording. So at the moment, you can, let's say simply, you can record data from many instruments as a function of one or more varying parameters. But if you want to do things sequentially with those parameters, reaching a stage where you want to measure something, that it's awkward at the moment to do it. So we are really pushing to make it more straightforward.
Oh, right. Okay. So more flexibility in the way people want to measure things.
Yeah, exactly. And especially in the community of biology or chemistry or some other area where they are really used to do their experiments in such a way, which was not the case in my direct area. So that's why it's been missing from the start. But we are correcting that. And that's why it's very important to meet people and discuss with their needs and so on. And the workshop we are organizing every year that will bring together about 50 people using or wanting to use PyMoDAQ and having discussion roundtables is really helping the development, really, because every time there's many new ideas coming up, and really I enjoy that, talking with those people and trying to meet their need.
Okay, so how do people get in touch with you if they want to find out more about PyMoDAQ? What's the best way of doing that?
So first of all, you reach the main page where sits the documentation. So it's called PyMoDAQ.cnrs.fr. And then there you'll get many communication channels. There's a Discord channel for PyMoDAQ. There's a mailing list. And there's also the GitHub main page where you can open issues, ask questions, whatever you want. So there's three main ways, Discord, mailing list, and GitHub.
Excellent. Well, thank you very much for your time. You're very busy, so I don't want to keep you any longer. Doing physics and PyMoDAQ is quite a lot. All the best.
Thank you, Peter.
By the time you hear this recording, Sébastien will have just finished a PyMoDAQ workshop in Montpellier in the south of France. But fear not, Sébastien also has a YouTube channel to help you get the most out of PyMoDAQ. And as per usual, you'll find all the relevant links in the show notes. And next week, the last Tuesday of November 2025, it's time for another non-English language episode. And since we're already in France, in a manner of speaking, with PyMoDAQ, it'll be a French episode. And for this I turn to two engineers, Simon Delamare and Guillaume Raffin, who will tell us why it's important to keep an eye on energy consumption in supercomputing centers and talk about the tools and solutions they came up with. I hope to see you then. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.